Hey guys, this video is to help you with dividing rational expressions. It's essentially the same thing as multiplying, but just with one extra step. So we're going to start the same way we do multiplication. We're going to factor the numerator and the denominator. Step 2 is we're going to change it to a multiplication problem. When you are dividing by a fraction, basically you're multiplying by the reciprocal. What you're going to hear me say is keep, change, flip. Essentially multiplying by the reciprocal. From there, you treat it the exact same way. You combine as one fraction, you simplify, and then always, always, always remember, list the excluded values, which can be a little bit more challenging with division because there's one extra thing we have to look for, but it's not too bad. So first example, we're going to begin by factoring the numerator and the denominator. So in my numerator, I have y plus 2, and I'm going to leave it alone. The denominator of the first fraction, y squared plus 10y minus 24. Once again, it's a trinomial. It's going to factor as two binomials. The first term is y squared, so it's y and y. The two numbers that are going to multiply to negative 24 and add to positive 10, positive 12, and negative 2. The numerator in the second fraction, a GCF of y can be taken out, so that's going to be y times y plus 2. And then in our denominator, y squared plus 2y minus 8, positive 4, and negative 2 will multiply to negative 8 and add to positive 2. After we're fully factored, we're going to change it to a multiplication problem. So we divide by the reciprocal, or you're going to hear me say the words keep, change, flip. What that means is I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So y plus 4 and y minus 2 are now in the numerator. Y and y plus 2 are now in the denominator. You heard me say the word combine. In my last video, we included an extra step of combining. Here, we've had a little bit of work with this. Basically, you're multiplying across. Everything is being multiplied in the numerator. Everything is being multiplied in the denominator. It becomes one single fraction. And from here, I can go through and I can cancel what factors I have in common. So I have a y plus 2 and a y plus 2, a y minus 2, and a y minus 2. So our final form is going to be y plus 4 over y times y plus 12. Now remember, excluded values are values that make the denominator equal to 0. When we look at this multiplication part here, it's pretty easy to see what excluded values we have. I crossed off a y minus 2. I no longer see it in my denominator. That's an excluded value of 2. I also crossed off this y plus 2. No longer see it. That's an excluded value of negative 2. The only other thing that you have to be careful of after you list the obvious excluded values is you have to look at what's in your numerator. If at any point in the problem this y plus 4 was in the denominator of either fraction, it's also an excluded value. So we have to look back through every step. In our original problem, y plus 4 was in the denominator of the second fraction. That means if it was in a denominator at any time, it has to be listed as an excluded value. This would be an excluded value of negative 4. So we have to make sure we include that in this problem. That's the one extra thing you have to do with the excluded values is make sure you look at the numerator and make sure that thing has never appeared in a denominator. If it has to be listed as an excluded value. So for our second example, we're going to start the same way that we've been doing these. We're going to factor. First fraction's numerator stays as x minus 3. Denominator factors to two binomials, the two numbers that multiply to negative 12 and add to positive 4, positive 6, and negative 2. In my second fraction, I have a GCF in the numerator of 2x. That leaves me with 2x times x minus 3, and the denominator stays the same, x minus 2. When it's division, we keep change flip. I keep the first fraction. I change to multiplication, and I flip the second fraction. So x minus 2 is on top, and then 2x times x minus 3 is on the bottom. Once you're at multiplication stage, you can go ahead and you can make this just one fraction. I'm going to draw my fraction bar across. This becomes one single fraction. Everything on top is being multiplied. Everything on the bottom is being multiplied. I can go through and I can eliminate x minus 2, and I can eliminate x minus 3. At this stage, I typically have a couple people that will say there's nothing left in the numerator. There's still something there. You can't put nothing. You need a placeholder of 1. So it's going to be 1 over 2x times x plus 6. For our excluded values here, we're going to start with the easy ones, what we can see from this stage of crossing out. I've crossed out in x minus 2. It's no longer there. That's an excluded value of 2. I crossed out in x minus 3. It's no longer in the denominator. That's an excluded value of 3. The thing we have to be careful of when we're working with division is looking at our numerator at the end. There are no factors or no terms with an x here, so we don't have to go back and look through and see if that was ever there because you no longer have x's. These are your only excluded values. Had there been something in our numerator like an x plus 7, then we'd have to go back and reevaluate it. But since there's just a 1, these are our only excluded values. Lastly, if you watched the multiplication video, you saw an example like this. 2x squared plus 2x is not a fraction, so I'm going to just make it into 1. I'm going to write this as a fraction over 1. I'm going to go through first and I'm going to factor. Now this one's a little bit more challenging because when you look at the numerator here, it actually can be factored twice. The first thing we should always look for is a greatest common factor, something that goes into each term. 6, 4, and 2 are all divisible or factorable by the number 2. So I'm going to take a 2 out. That's 3x squared plus 2x minus 1. 5x squared is a monomial. That means it can't be factored, so we just rewrite it. Divided by, in the numerator of the second fraction, I have a GCF of 2x. Remember, if you have two terms, you should still have two terms on the inside. So even though you're taking 2x from 2x, you need a placeholder there of 1. We're left with x plus 1 on the inside, all over 1. You can still factor this problem further. 3x squared plus 2x minus 1, you have a trinomial. Trinomial factors to two binomials. The thing that makes this a little bit trickier is your first term is not just an x squared. The way that we multiply to get 3x squared, the only way that we can multiply to get 3x squared if we're factoring is 3x times x. The only way that we're able to multiply to get 1 is 1 times 1. The last thing that we have to think about would be our signs here. You're multiplying to a negative, which means 1 needs to be a plus and 1 needs to be a minus. Where each of them goes is based on this term here, this positive 2x means you need more positive x's than you need negative x's. So if you were to go through and FOIL this out, 3x times 1 is going to give you a lot bigger value than just x times 1. That means the positive has to go here and the negative has to go here. And then our second fraction, we're just going to rewrite it because it can't be factored any further. Once you're in the most factored form, we need to multiply by the reciprocal, so we need to keep change flip. Just rewrite the first fraction. Change to multiplication, and flip the second one. Once we are at the multiplication stage, we can create this as one big fraction. And I can start eliminating x plus 1 with x plus 1. I have a 2 in the numerator and a 2 in the denominator, so those can be canceled out. What you're left with at the end is 3x minus 1 over, when I multiply these, this 5x squared times x, that's going to give me 5x cubed. And we want to think about our excluded values. Start with the easy thing. We've crossed out an x plus 1. That's an excluded value of negative 1. We did eliminate a 2 from the numerator and the denominator, but because it didn't have a variable with it, we don't count that as an excluded value. That's just simplifying a fraction down. Last final thing that we have to do is we have to focus on this numerator here, 3x minus 1. We're going to go back through to the original and we're going to see if 3x minus 1 ever appears in the denominator. It's not in this step, it's not in this step, and it's not in this step. So in this case, we don't have to list 3x minus 1 as an excluded value because it only ever appears in the numerator. Your only excluded value for this one is going to be negative 1.